So we're going to wind up our discussion of wide area networking with a discussion of frame relay. And this is a very basic discussion of frame relay. It's practically nothing. It's just a couple of minutes to tell you what it is and basically how it works, and the two different types of connections inside of frame relay. And you might feel like you're getting a little shortchanged, but at the CCENT level, this is really all you need to know about frame relay. If you continue on with the CCNA, and of course with the CCNP, you'll get pretty in-depth in frame relay configuration. But for now, let's just go over what you'll need to know for the exam. Frame relay is a layer 2 packet switching protocol. And the nice thing about frame relay is it allows you to have a single WAN connection at your data center or at all of your branches, yet connect to multiple different endpoints. You can probably imagine, before the advent of frame relay, if you had a network that had 25 different locations, then you had to have 25 different point-to-point connections, all terminating into a single router or a few routers probably at that stage of the game. And you had to configure routes to all of those locations on each of those interfaces, and you can imagine that it became very unwieldy. Frame relay allows you to connect your network to a frame relay provider. You hand your data to the frame relay provider, telling the frame relay provider where it needs to go, and the frame relay provider then drops that data on the other end of the network where you've told it to go. To put it more succinctly, it uses virtual circuits to transport the data from one logical network to another. Now, these virtual circuits, again, they're logical connections. They enable communication between any two devices on your network. Virtual circuits are bidirectional, and they allow both the remote device to connect to you as well as you connect to them, which I guess is the definition of bidirectional, so I just kind of explained myself there. Now, there's two different flavors of circuits inside frame relay. The first is the switched virtual circuit, or the SVC. Switched virtual circuit means that if you're going to send a packet from network A to network C, then that means the frame relay provider has to dynamically build that circuit between those two networks, send the data through the circuit, and then bring it down. You can imagine there's a lot of latency with that, as it has to establish the connection through their frame relay cloud. SVCs are hardly ever used, if ever. I don't think I've ever seen a switched virtual circuit on a production network. The one that's more commonly used is called a permanent virtual circuit, or a PVC, and it's basically a nailed-up connection between two endpoints. It's always there when you need it. You send the data on one end of the PVC, and it lands on the other end of the PVC. Now again, frame relay is a logical construct, so you hand your data to the frame relay provider. It may go through 27 routers inside their frame relay network. You'll never know it, even by doing a trace route, because all you see is it enters their network and it leaves their network. And it doesn't really show you what happens in between. Frame relay is a very cool technology. It is the basis for such technologies as MPLS, which allows you a much more flexible control over how your traffic is prioritized and routed through the frame relay or MPLS provider's network. However, for the CCNT, this concludes our discussion of frame relay basics.